Stars die. It's a simple yet profound truth of our universe. It sounds dramatic, but it's true. The life cycle of a star is a grand cosmic tale. The twinkling points of light we see in the night sky won't last forever. Each star has a beginning and an end. They're engaged in a constant battle against gravity, and eventually, gravity wins. This struggle defines their existence. But their deaths are not quiet events. They are far from silent. They are spectacular displays of energy, shaping the universe around them. These events leave an indelible mark on the cosmos. These cosmic firecrackers, as I like to call them, come in different sizes and intensities. Each one is unique in its final moments. Some stars go out with a whimper, fading quietly into the darkness, while others erupt in a blaze of glory, lighting up the universe one last time. Their final act depends on their mass, the very thing that defined their lives. The mass determines whether a star will become a white dwarf, a neutron star, or even a black hole. Smaller stars like our Sun will end their lives as white dwarfs, slowly cooling over billions of years. More massive stars may collapse into neutron stars, incredibly dense remnants of their former selves. The most massive stars of all can end their lives in the most dramatic fashion, collapsing into black holes, regions of space where gravity is so strong that not even light can escape. And yet, from these stellar deaths, new life can emerge. The dust and gas expelled by dying stars can form new stars and planets, continuing the cycle of creation and destruction. In this way, the death of a star is not an end but a new beginning, a stellar farewell that paves the way for new wonders in the universe. Stars spend most of their lives fusing hydrogen into helium in their cores. This process releases enormous amounts of energy, the energy that makes them shine so brightly. Think of it as a star's internal engine, keeping it going for billions of years. However, this fuel source isn't infinite. Like a car running out of gas, stars eventually deplete their hydrogen reserves. This marks the beginning of their end, a slow and fascinating decline. As hydrogen dwindles, a star's core contracts under its own gravity. This contraction increases the core's temperature and pressure. Eventually, it becomes hot and dense enough to fuse helium into heavier elements like carbon and oxygen. This fusion process provides a temporary reprieve, a second wind for the aging star. However, it also causes the star to expand significantly, transforming it into a red giant. The fate of a star is intricately tied to its initial mass. This fundamental characteristic determines the entire life cycle of the star, from its birth to its ultimate demise. Smaller stars, like our Sun, follow a relatively gentle path. As they age, they expand into red giants and eventually shed their outer layers into space, creating a stunning display of solar flares and ejected material. This process results in the formation of a planetary nebula, a beautiful and colorful shell of gas that expands outward into the cosmos, often creating intricate and mesmerizing patterns. The core that remains after this shedding is known as a white dwarf. This dense, hot remnant will slowly cool and fade over billions of years, gradually becoming a cold, dark cinder in the vastness of space. Larger stars, however, have a much more tumultuous end. Their immense mass leads to a series of increasingly violent and dramatic events. In these massive stars, the core continues to fuse heavier and heavier elements, creating an onion-like structure with layers of different elements stacked upon each other. This fusion process can only continue up to a certain point. When the core reaches iron, fusion no longer produces energy, marking the end of the star's ability to sustain itself. At this critical juncture, the balance between fusion and gravity is disrupted. Gravity takes over, leading to a catastrophic collapse of the core. This dramatic event can result in a supernova explosion, leaving behind either a neutron star or a black hole depending on the remaining mass. Section 5. When gravity conquers the black hole's birth. For the most massive stars, the core collapses in on itself in a fraction of a second. This collapse triggers a shockwave that rips the star apart in a supernova explosion. If the core's mass is large enough, it continues collapsing until it forms a black hole, an object so dense that not even light can escape its gravitational pull. Black holes are enigmatic objects shrouded in mystery. They represent the ultimate victory of gravity, where matter is compressed to an infinitely small point. Section 6. Supernovae cosmic fireworks displays. Supernovae, on the other hand, are the most luminous events in the universe. They briefly outshine entire galaxies, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. These explosions are essential for life as we know it. The intense heat and pressure during a supernova forge heavy elements like gold, silver, and uranium. These elements are scattered throughout space, eventually becoming incorporated into new stars, planets, and even life itself. Section 7. Stellar recycling. From death comes life. In a sense, stars are like cosmic recycling plants. They take simple elements like hydrogen and helium and transform them into heavier elements. Their deaths, whether quiet or explosive, enrich the universe with the building blocks of planets and life. Without stars, the universe would be a very different place. It would be a cold, dark, and lifeless expanse. Stars are the engines of creation, driving the evolution of galaxies and the emergence of complexity. Section 8. Our place among the stars. A final thought. The next time you gaze up at the night sky, remember that you are witnessing a cosmic ballet of life and death. Each twinkling point of light represents a star, some young, some old, all destined to meet their end in a spectacular display of energy. And from their ashes, new stars will be born, continuing the cycle of stellar evolution. We are all made of star stuff, connected to the cosmos through this intricate web of cosmic processes. So take a moment to appreciate the beauty and wonder of the stars, for they hold the secrets to our past, present, and future. When you look at the Milky Way, you are seeing a galaxy that is home to billions of stars, each with its own story. Some stars are just beginning their journey, forming in the dense clouds of a nebula. Others are ending their lives in a brilliant supernova explosion, scattering elements across the cosmos. Around many of these stars, planets orbit, some of which may harbor life. Our own planet, Earth, is just one of these countless worlds, a tiny speck in the vastness of space. As we continue to explore the universe, we are constantly reminded of our place in it. We are not separate from the cosmos. We are a part of it, connected by the very atoms that make up our bodies. So the next time you find yourself under a starry sky, take a moment to reflect on your connection to the universe. Remember that you are a part of this grand cosmic story, a story that has been unfolding for billions of years and will continue to unfold for billions more. Embrace the wonder and mystery of the stars, for they are a reminder of the beauty and complexity of the universe we call home. And as you do, know that you are not alone. You are part of something much larger, something truly magnificent.